All right, so let's continue our discussion on some applications of linear equations. So this time we have this second word problem example. And again, as we read the problem, make sure that we underline some important information and read it thoroughly, okay? Researchers have surveyed college freshmen every year since 1969. Um, Oh, the figure shows that the attitudes in some have like goals, blah, blah, blah. In particular, the freshman class of 2010 was more interested in making money than the freshmen in 1969. So in 1969, okay, 42% of first year college students considered being well off financially very important. So the question here, from 1969 through 2010, the percentage increased approximately by zero point 0.9 each year. So if the trend continues, by which year will all college freshmen, so that's the question, all college freshmen consider being well off financially essential or very important? Okay. So for this particular problem, we have a starting point, which was 1969. And from then, it says that 42% of the freshman college thinks that being well off is important. Okay. So we know that there is that starting point. Now, the years pass by, and every year there was an increase of zero point 0.9. Okay. How many years passed? We do not know, but we know it's gonna be somewhere between 1969 and so this trend of zero point 0.9 each year that was observed from 1969 through 2010. So if that was the trend and it continues beyond 2010, okay, in which year, by which year will the freshmen, all college freshmen, consider being well off as very important or very essential? Okay, so how are we going to represent this problem? So do we know how many years has passed before we can identify how many of the freshmen thinks that being well off is important? We do not know. So that is our X. Okay, X is the number of years after 1969. Okay, after 1969. So pretty much what will happen here is we have a starting point. Remember, in 1969, how many percent of the freshmen? It was 42% of the college freshmen in there. So from 1969, it increases by 0.9, increase 0.9 each year. So because there is a 0.9 each year, we do not know how many years, then we can represent this as 0.9x, okay? Because we do not know how many years, okay? So the question is, how many years should pass before 100% of the college freshmen will think that being well off financially is very important? So we already have a starting point, which is 42, okay? So the percentage, which is 42, and then every year it increases by how many? By 0.9, all right? And we do not know how many years. So our goal is from 1969, how many years should pass before all or 100% of the freshmen believes that being well off financially is important. So this is how our equation would look like. All right? So from here, we can solve for our x, okay? So we have 42 plus 0.9x is equal to 100. So we already have our x on the left side, so we need to we need to remove or undo our plus 42. So minus 42, that is 0 now, minus 42. So on the left side, we have 0.9x is equal to 100 minus 42 is going to give us 58. And now if we have to solve for x, we simply divide this by 0.9 we divide 58 by 0.9. And using your calculator, the x value will give us around 64.4, and it's going to be repeating. So if we're going to give an estimate or an approximation, we can say that x is going to be equal to 64. So what does this mean? After 64 years, that is pretty much the time after 1969 for all the freshmen to be 100% believers that well off financially is important, okay? And you can always check, okay? You can replace your x here. So you can have, so to check, all right? So checking, so 42 plus 0.9 times 64, is this going to be equal to 100? So 42 plus, okay, if you get your calculators, you will have, so this is going to be 0.9 times 64, so that's 36, carry 3, 54, so that's around 57.6. Is this going to be equal to 100? So if you add 42 and 57.6, all right, you will see that this is going to give us around 99.6. Okay, again, the 64 was an approximate. 99.6, is it very near the 100%? Very much. Okay, so 64 years after 1969 is when we can expect that 100% of the college freshmen will believe that being financially well off is very important. All right. So the next part of this discussion is going to talk about formulas, okay? So as I have mentioned before, formulas are pretty much like, you will see a lot of variables in there, but they are not random letters in there. They represent specific values or quantities, and formulas show different relationships, all right? Now, when you are working with a formula, you have to treat each variable or each quantity as a number. So whatever operation you are doing, you just do the same thing, whether it's a plus or a minus a or something like that. The only thing different is that you cannot combine, you cannot perform the operation, because you might be adding or subtracting one variable to another variable, which you cannot combine. Like, I mean, from the term itself, we cannot combine like terms. So you just leave them operations as they are, all right? So let's have this example. The total price of an article purchased on a monthly deferred payment plan is described by the following. So T is equal to D, capital D, plus PM. Now, it is important. If you see it a capital letter, leave it as a capital letter. When you type it on MATLAB, it has to be capital letter as well, or else it will be marked wrong. So what do these letters or what do these variables represent? T is the total price, D is the down payment, P is the monthly payment, and M is the number of months that one pays. So in this question, in this problem, we need to get the formula and solve for P, okay? So what does that mean? We want P to be by itself. Okay, we want only P to be by itself. If you will notice here, T is the one by itself. So we need to rearrange this formula in such a way that our goal is to make sure that P is by itself. So how do we do that? Now, if you are going to analyze, P is multiplied to M. So we cannot remove M yet because there is this plus D. So how can we undo plus D? The opposite of that will be minus D, okay? So you subtract D on both sides. So this is now a 0, okay? So on your right side, you have P and M, okay? On the left side, as you can see, you cannot combine D and T because they are different quantities. So leave the expression as it is. It will stay as T minus D. Okay? Leave it as it is. You cannot combine them. Now, take a look at our P, we want P to be by itself. P is multiplied to M. And how can we remove the M? Because it's multiplied by M, we need to divide by M. Divide by M, this will give us 1. We need to divide the left side, all of it, by M. And so now, we can see that P is by itself, okay? And what is it corresponding to? The value of T minus capital D, divide it by M. This is now the formula if we are solving for P, okay? Again, it is important to understand whatever you do when solving equations, add, subtract, multiply on both sides, divide on both sides, you can also do that in formulas. The only thing different is that you cannot evaluate the number itself. So for example, if you have 35 divided by 5, it will end up being 7. Here, if you have T minus D, because there are no quantities there, leave them as expressions. All right? That is how you can manipulate, that is how you can rearrange your formulas if you are solving for a specific variable. So your goal is to isolate that variable and then look back and do all the operations for the other variables together with that target variable. And that's everything for applications of linear equations.